In this lesson on acceleration time graphs, you're going to be able to graph the corresponding acceleration time graph when given a velocity time graph. So the process for converting from a velocity time graph to its corresponding acceleration time graph is the same as going from a position time graph to a velocity time graph. That is, we work out the slopes on the velocity time graph and then we make them the y values on the acceleration time graph for the same time. For example, if we wanted to figure out what the acceleration time graph would look like for just this part of this velocity time graph, the question we need to ask is, what's the instantaneous acceleration at any moment in this time interval? To find the instantaneous acceleration, we need to find the slope of the tangent. So let's say we wanted to find the instantaneous acceleration at 1 second. Although I'm drawing this below, I really mean it superimposed on the line. We need to find the slope of that tangent. At 2 seconds, we need to find the slope of that tangent to find the instantaneous acceleration, etc., etc. And at the times in between the seconds as well. Now, luckily for us, because this is a straight line segment, the instantaneous acceleration, that is the slope of the tangent, is equal to the average acceleration, the slope of the secant, and in fact the secant is just the line segment itself. So we can find the instantaneous acceleration at any point in this time interval just by finding the slope of that line segment. So the slope of that line segment is the rise, which is 4 meters per second, and I'm going to use positive to indicate that it's right, and that's happening over a run of 4 seconds. So the slope is 1 meter per second squared, and positive because it's to the right. Carrying on the same process here, acceleration, the instantaneous acceleration at any point in there is 0. Here we've got a rise of -4 in 1 second, so the acceleration is -4 meters per second squared. Here the acceleration is 0. Here the rise is -3 over a time of 2 seconds, so the acceleration is -1.5 meters per second squared. And here we have a rise of 3 meters per second in the positive direction, going from here to here, and that's happening over 6 seconds. So that's 0.5 meters per second squared as our acceleration. Now we just need to turn these into our y values for the same time intervals on the corresponding acceleration time graph. For the first 4 seconds above, we had a slope of +1, so here we need y values of +1. Then for the time interval of 4 to 7 seconds, we had a slope of 0, so here we need y values of 0. Then from time 7 seconds to time 8 seconds, we had a slope of -4, so here we need y values of -4. Then to 12 seconds, we once again had a slope of 0, so y values of 0. Carrying on, we had a slope of -1.5, and then a slope of +0.5. Then all of those should be joined by straight vertical line segments because the acceleration was changing instantaneously. And that's our acceleration time graph that corresponds to the velocity time graph we were given above.